Welcome to myprojectbazaar.com.
Title of our product is Reducing Power Leakage and Area of Standard Cell ASICs using Threshold Logic Flip-flops. Abstract of our product is: in this process we describe a new approach to reduce dynamic power leakage and area of application specified integrated circuits without sacrificing performances. The approach is based on the design of threshold logic gates and their seamless integration with conventional standard cell design flow. We first describe a new robust standard cell library of configurable circuits for implementing threshold functions abstractly. The threshold gate behaves as a multiple input single output edge triggered flip-flop which computes a threshold function of the inputs on the clock edge. The library consists of a small number of cells, each of which can compute a set of complex threshold functions which would otherwise require a multi-level network. The function realized by a given threshold gate is determined by how signals are mapped to its input. We present a method for the assigned of signal to the input of a threshold gate to realize a given threshold function. Next, we present a algorithm that replaces a subset of flip-flops and portion of their logic counts in a conventional logic netlist with threshold gates from the library. The resulting circuit, which both conventional and threshold logic gates are placed and routed using commercial tools. We demonstrate significant reductions in power leakage and area of hybrid circuits when compared with the conventional logic circuits when both are operated at maximum possible frequency of the conventional design. Now we are going to discuss about the flow diagram of our product. Our product can be implemented by using three different units. They are input network unit, sensing unit, and symmetric SR latch flip-flop unit. These input network units consist of two different inputs. They are right input network and left input network. Both are manufactured by using a PMOS and NMOS component. The input clock signal can be applied into these two right and left input network. This cell can be operated based on three components. It consists of three main components. They are two groups of parallel p-FET transistor referred to as an input of left side, a sense amplifier which consists of a pair of cross-coupled NAND gates, and then another last one of the component is a set reset latch. The cell operation can be run by two different phases. They are reset phase and another one is an evaluation phase. Reset phase will be worked based on the clock is equal to 0. The evaluation phase is worked based on the clock will be changed into 0 to 1. When right input network and left input network output will be considered as an N5 and N6. The output of a N5 and N6 can be directly applied into the sensing amplifier. This sensing amplifier will produce the output waveform. They are denoted as an N1 and N2. They are directly applied into the set reset latch. This is otherwise called as a symmetric SR latch. They will produce the final output of Q. They can be fully dependent on the external input clock signal of a symmetric SR latch. Now we are going to discuss about the Running procedure of our product. Our product can be implemented by using a Tanner EDA tool 13.0 version. Now double click to open the tool window. First create a new design using file option. File to create a new design. We are name our design for this design name option. When they are save as an desired path. After creating the file, now we are going to add the library files from this add option. Add to select the Tanner EDA library path. After selecting the library path, click OK. After creating the library files, now we are going to create a new cell for a schematic design. Create a new cell from the cell option cell, new view. Now we are give the cell name in this cell 0 option. Edit the name, click OK. In our product we are using two different cells to implement our product. They are PNAND cell and PNAND cell design with the scan implementation. First we are going to run the PNAND cell. Select PNAND and start simulate using start simulation option. This is an output waveform of a PNAND cell. Expand this waveform using expand chart option. This is V clock is an input clock signal. Vn1 and Vn2 is an output of the sensing amplifier as well as an PNAND cell output signal. Now we are going to simulate the PNAND cell design with the scan. Select this cell and start simulate using start simulation option. This is a final output of a PNAND cell design with the scan implementation. Expand this waveform. VT1 and VT2 is an external clock of the symmetric SR flip-flop. Q bar and VQ is a final output of the symmetric SR latch. Vn1, Vn2 is an PNAND cell output signal. V clock is a given input signal. Thank you for watching this video.